Welcome to the Calculus Building. I'm Gregory Carlson. Let's look at an example of a limit. As x approaches 1, the value of 2x plus 5 approaches what? Well, let's see what we've got. We have a function, f of x, which is equal to 2x plus 5. That's our function. And we want to know what is the limit as x approaches 1. That's the value we're approaching. So as x approaches 1, what is the limit of 2x plus 5? So that's what that means symbolically. The limit as x approaches 1 of 2x plus 5 is equal to what? So here's how I know a scholar doesn't understand what a limit is. If you just take the value 1 and just plug it in and crunch it, that tells me you don't understand the concept. Because remember, limits are not a value. Limits are something that we approach. They're something that we want to get to. They're not necessarily equal to the value when we plug in the number here. In this case, it's going to be that, but it's not always the case. So let's do this. Let's find out what is the limit as we approach from the negative side. So what is the limit as we approach 1 from the negative side? And what is the limit as we approach 1 from the positive side? Okay, so that's what we're going to do. And to do that, we're going to look at a table. So I'm going to make a little table. And right here in the middle of the table, I'm going to put the number 1. Okay, so that's what I'm going to do. Let me fix my light. That's what I'm going to do. And we're going to approach it from the negative side. So I'm going to do negative 2. Let's start at negative 1, 0, 0.9, and 0.999. So that's what I'm going to do. We're going to calculate those values of our function. And then on this side, we're going to start, let's say, at 2. Then the next value we're going to plug in is 1.5, then 1.01, and then 1.001. Okay? So notice that I'm approaching it from both sides. I'm approaching it from the negative side, negative 1, 0, 0.9, 0.999, and I'm approaching it from the right, from the positive side, 2, 1.5, 1.01, 1.001, and 1. So let's calculate what these values are by plugging them in. If I plug in negative 1 in here, I get negative 2 plus 5, which is equal to 3. If I plug in 0 into the function, f of 0 is 2 times 0 is 0. 0 plus 5 is 5. So that number right here is going to be 5. I'm going to use my calculator for this. Let's plug in 0.9. So 2 times 0.9 plus 5. So we see that if I plug in 0.9, I get the number 6.8. So it looks like we're getting bigger, 3, 5, 6.8. Let's try plugging in 0.999. So 0.999 times 2 plus 5. 6.998. So what number does it look like this is approaching? 3, 5, 6.8, 6.998. In fact, let's just do one more. I'm not going to write it down. Let's do 0.99999 because we're approaching 1. So times 2 is equal to plus 5 is equal to 6.9999998. Based on this, it appears that the limit we're approaching from the negative side is equal to 7. That's what it looks like we're approaching. Let's try it from the other side. Let's plug in a 2. Again, 2 times 2 is 4, plus 5 is 9. Now let's try plugging in 1.5. 1.5 times 2 is 3. 3 plus 5 is 8. So it looks like we're starting at 9, and now we're getting smaller. Let's try plugging in a value that's a little bit bigger than 1. 1.01. So 1.01 times 2 is equal to 2.02, plus 5 is equal to 7.02. How about 1.001? So we're just a hair bigger than 1. Plug it into our function, times 2 plus 5. 7.002. So as you can see, it looks like we've gone from 9 to 8 to 7.02 to 7.002. Let's do one more kind of crazy one. Let's do it just a tiny bit bigger than 1. Okay? Times 5 plus 2. And you can see we're just a hair above 7. And so it appears to me that the limit as we approach from the positive side is also equal to 7. So as we approach from the negative side, as we approach 1 from the negative side, we appear to approach 7. As we approach 1 from the positive side, it appears to approach 7. So what is the value actually at 1? And here's what's really important. It does not matter. If we are only concerned about the limit, okay, it doesn't matter what the value is at 1. We just want to know what are we approaching from the left and what are we approaching from the right. It's only going to matter what 1 is when we get to something called continuity. But the truth of the matter is it shouldn't matter, and you need to do a lot of work to find this limit. You saw I had to do a lot of calculations to find this limit. Now it turns out that when I plug in 1, I get 2 times 1 is 2, and 2 plus 5 is 7. So yes, the value is 7 when we plug in a 1. But as far as the limit is concerned, it doesn't matter what the actual value is of 1, just how we approach it. Let's also see this limit as on a graph. So to graph the line 2x plus 5, I have a y-intercept of 5, then it's up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. That's what my line looks like. Sorry, it's supposed to be straight. Just pretend that that's straight. And we want to know what is the limit as x approaches 1. What is the limit? What is f of x when x approaches 1? And you can see that from the left-hand side, we appear to be approaching the value of 7. And from the right-hand side, we appear to be approaching the value of 7. So because those two values are approaching the same value, that means our limit is 7. And it just so happens that that happens to be what the function is at 7. So I hope all of this makes sense. Limits take a lot of work to figure out. You need to keep plugging in numbers, getting closer and closer and closer to the value you're trying to reach, and getting closer and closer from the right-hand side to the value you're trying to reach. So I know that one example took a long time, but it's important for me to let you know why the actual value there doesn't matter when you're talking about a limit. It's just about what value is our function approaching from the left and the right. You'll see a little bit more why this actual value doesn't matter in the next video, and I'll see you there.